All right, displaying quantitative data. How do we present it to people? Once we get this data, how do we present it? Well, there are three common ways. Stem plots, dot plots, box and whisker. So let's go over this first. Here's the Summit Golf Team scores for 18 holes. All right. So a stem plot. So a stem plot, what you do is you don't do that. You get the marker. All right. Now, for a stem plot, you're going to look at the tens digit. Okay. So what's the lowest number? 70. Right. So we have scores in the 70s. We have scores in the 80s. We have scores in the 90s. We have scores in the 100s. And since we had that one way up at 131, we have, I'm sorry, I didn't write 100, I meant to write 10. We're going to have to go 11, 12, and 13. Then we draw a line. This is the stem, this side. Okay? If you think about leaves, they grow off the stem, and that's what we're doing here. We're going to take all the single digits and put them over here in order. So we're going to do the 70s first. So let's find the 70s. This is just a way to organize, make sure I get them all. So now we're going to write them in order. So 70 is 70. I'm going to cross it off so I know I got it. 75 would be next, and you kind of want to do it neatly so you have kind of columns. You don't draw lines. The only line you draw is this first one separating the 10s and the 1s, but still try to keep it organized. So 75, then 78, and then 79. And I'm going to double check and make sure I don't have any other 70s. It happens. Good to go. Now 80s. 82, 88, 84, 88, and 80. So, lowest number is 80, so I put the 0 here. I cross it out. I have 82, so I put a 2 directly underneath the 5. Remember, try to keep it neat and orderly. Then I have an 84. I have an 88. And I have another 88. And if I make a mistake and find a number I missed, I just go back, erase, and move numbers. That's okay. 90s. 1, 2, 3 numbers there. So for 90, I put a 0 here, 91, and then 95. So I'm going to put a 5 here. Now, do I have any numbers in the hundreds? Yes, I do. I have 100, okay, 100, and 102, 102. Do I have any numbers in the teens? 1 something? No, I do not. I don't put a 0 there because that would represent 110. I'm just going to leave it empty. If it makes you more comfortable, if you want to put a line there, that's fine. I have no 120s, and I have 130, 131. And now all my numbers are crossed off. That is a stem and leaf plot. Okay, a dot plot. We've done this in class. Okay? We got to go from 70 to 130. Okay? So I'm going to put 70 here and just try to make it, I'll put 130 maybe here. You know, 80, 90, 100, 110, 120. You can make it more spread out if you want on your paper. It doesn't matter. So, 70 is going to be right above there. 75 is going to be right in between. 78 there. 79 almost to 80. Then I'm going to have an 80. I'm going to have an 82. 84. And then 2 88s. And then I'm going to have a 90. A 91. 95 is in the middle. I have 100, I have 102, and then I have 131. That is a dot plot. And I know it's got X's. You can use big circles if you want. Circles, X's, whatever. It's fine. Okay, so which tells us more about the data and why? Okay, so for this data set, which tells us more about the data and why? Me personally, I kind of get the same information from both. So they both show the majority of the data is from like around 70 to 100. I mean 102 technically, but in that range. And then 131 is what we call an outlier. Now, what does left skewed, negative skewed on a stem plot look like? And what about on a dot plot? Well, the tail of the whale, you want to look for the tail. When something is skewed, it's away from the norm. Okay? So if you're looking at a graph and majority of the data is down here, but there's some data up here, but most of it is in here. I'm just thoughtfully getting the idea here. Most of your data is there to the right, but some is on the left. It's being pulled to the left. Okay? Think about this. Negatively skewed is when most of the class does well in the test, but a couple kids bomb it. Okay? That's down here. That's pulling the class average down, isn't it? So it's negatively skewing it. All right? And basically, if you think about a stem and leaf plot, it's kind of the same thing. You just kind of can turn it on its side, and it's going to look the same way. So if you drew, like we go back up, and I drew kind of, whoops, missed it. And just look at it that way, same idea. The tail is going to be here, and most of your data is going to be down here. Okay, so there's going to be a few things on the lower end, because those numbers are lower numbers, pulling away from the higher end. So it's basically the same picture, just turn on its side. That's it. Same thing here. So positively skewed is when the majority of the class does poorly, but then a couple kids do better. And what do? They pull the class average up. If you didn't have those two kids, the scores would be worse. The class average would be worse. So they're positively skewing it. And then again, if you just look at it this way, the majority of the data is the lower numbers, but then you do have some down here pulling it positive. Is the data normal or skewed? I would say it's pretty normal. It's very close to normal. If you take the outlier out, if you look back at your data on page 1 of the notes, obviously, there's more data left of 88, a little bit further down, okay? 70 is a little further from 88 than 102 is. But if you look in here, that's kind of centered around there. It's a pretty normal graph. If we're going to call something skewed, we want to see kind of a dramatic amount. Okay, so we look for normal, left skewed, or right skewed. So if you look at this, it's not perfect, but that's pretty normal. Okay, and if you do this and you kind of drew where it would be, all right, most of your data is higher for the day students. So on the day students, I would say it is negatively skewed. Because why it's not drawing. That's a D there. These scores are kind of pulling the average down. Now for the evening students, Pretty normal. So since we're looking at two groups, even though it's on one plot, stem and leaf plot, okay, it can still have different results. And also, we didn't talk about this, but on the day students here, this number here represents 28, and then 32. This number is still our stem. So, this is 20 and 25, 36, and so on. So you always put that number as the tens digit, all right? So for the day students, 28 and 32 especially are pulling the average down. They're not far enough away to be outliers. I guess if you wanted to, you could count them out, and if you did that, then it would be more normally skewed. But again, that's the beauty of statistics. You can kind of play with the data. Now here is what I was talking about. We have a definite tail. Now, where is the tail of the whale? It's on the left side, the negative side. So this is going to be negatively skewed. That's supposed to be K. All right? All right. Quartiles. What are quartiles? You get quartiles when you divide the data into 4 equal groups. The interquartile range is Q3 minus Q1. And you already covered this in Algebra 2, and we'll be going over this again here. All right. Quantitative data can be described by a 5-number summary. The 5 descriptors are the minimum, Q1, the median, or Q2, Q3, and the maximum. All right? And then here is your interquartile range, your IQR, interquartile range. This is the difference between those two. And your range is right here, low to high. Okay? Low to high is your range. IQR is the Q1 to Q3 size. Okay? So, a box plot uses these 5 numbers and splits the data into fourths. 25% of the data are represented by each section. So there's 25% here, 25% here, 25% here, and 25% there. All right? So find the 5-number summary for the following test scores for our statistics class. Now we're going to practice this in class, but I'm going to show you how to do it easily on the calculator. Now you can do it mathematically, but it requires rewriting all these in order, okay, which they're not, which is kind of a pain. But basically, if you rewrite them in order, you find the middle number, the median, and there's 2, 4, 6, 8, 10, 12, 14. So the median is going to be halfway between the 2 middle numbers. Then all you do is find the median of the left side and the median of the right side. Very simple. I'm going to show you how to do it on the calculator, and we'll practice this in class. All right? So, hopefully you remember this from Algebra 2. You go to Stat, you go to Edit. I'm going to go over to my L1, which I don't have, so let's go to L3. And I'm going to go up, and I'm going to hit Clear. Not Delete, Clear, and come back down. It empties my data set. I'm going to put these numbers in. 72, 90, you want to fast forward to the end of this part, 78, 95, 87, 84. I'm going to just double check real quick. I got all the numbers so far. 78, 95, 87, 84. 80, that's the point. 97. I'm double checking them as I go. 70, 55, 73, 85, 87, and 90. Again, decimal, 90. Okay, after I have those in, I go back to Stat. I'm going to calculate. And I just go to one variable statistics. Simple. And I'm going to tell it which one to look in. So I'm in L3, I'm going to keep it there. If it was L1, you just hit second, 1, 2, 3, whatever number it's in. And you just hit enter a few times. And then you scroll down, and here's your 5-number summary. So it's 14 numbers, we counted that. The minimum is 55. The maximum is 97. So this is 97. That is 55. My median is 84.5. My Q1 is 73, and Q3 is 90. So 73 and 90. There's my 5-number summary. Okay? And if I was going to make a box plot out of that, I'm just going to come up here and do it. I would just write 55 under here, 73 under here, 84.5, 90, and 97. And I would label this, low, high, median, Q1, Q3. All right? That's it. Now, what would change if the test score 85 was removed? Okay? You can hypothesize that, or you can actually go into your calculator, go back into your data, find the 85, and delete. And then run your stats again. Calculate, enter, 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 and let's see what happens. Now I have 13 numbers. My minimum and my maximum did not change, obviously. But look at the median. What happened? It went down. Okay? Since the 85 was higher than the median, that was pulling it right. Taking the 85, taking any number right of 84.5 shifts the median down. It shifts Q1 down. It did not touch Q3. Okay? So it lowers the median and Q1. Construct a box and whisker plot of the original data of test scores and find the IQR. Well, I've already done that. I already did on the previous one. So we can just refer back to that. We did that right there. There's my box plot. My IQR is going to be 90 minus 73. So that's 17. The interquartile range is 17. What does a left skew and right skew look like on a box plot? So we'll put left here, and we'll put right here. So again, we're going to look at the tail. So if I have my low here, and my box is kind of up here, and my tail is to the left, that's left skew. And then you just flip it. I have a long tail here. That's going to be right skew. Okay, I just realized I kind of made a mistake. That was on the generic, kind of pretty even box plot. So let's actually do number 13 again here. So we're going to put our low and our high. Okay? And our low was 70. And our high was 97. Okay? Now, that's about 30 in between, right? 97. But what you do is you want to find out what the middle number is. Okay? Just kind of get an estimate of the middle right here. We don't really want to mark it, but we're just going to say 97 plus 70 divided by 2. So that's where 83.5 goes. All right? Well, what was our median? 84.5. So the median is pretty close to that. So I'm going to put a line right here and put 84.5. All right? And then my Q1 and Q3 were 73 and 90. So, where's 70 going to be? 73? It's going to be much closer to 70 than it is 84.5. But let's do that. 84.5 plus 70 divided by 2. And that's 77.25. So this is like 78 right there. So where's 73 going to be? About right here. And I'm not going to measure, but you want to kind of make it realistic. All right? So there's 73. And then, wrong way. And then 90. Okay? Well, what's halfway between 97 and 84.5? 97 minus 84.5 divided by 2 is, sorry, I meant to say plus. 97 plus 84.5 divided by 2 is 90.75. So 90 is really close to the center here, so I'm just going to go a little bit left of that and put 90. And then I connect my Q1 and my Q3. Okay, so here's something I never knew before from the stats unit. This is pretty cool. The 1.5 IQR rule. We're going to take that IQR of 17 and multiply it times 1.5. And that's going to give us 25.5. Now, what we're going to do with that is we're going to take Q1 minus 25.5 and Q3 plus 25.5. And those are going to give us our boundaries to see if something's truly an outlier. All right? So, Q1 was 73. So 73 minus 25.5 is 47.5. And 90 plus 25.5 is 115.5. That is our boundary. If anything is outside of that, it is an outlier. Well, our lowest number 7, our biggest number 97, so no outliers on this one. So you don't go by, well, it looks like it's an outlier. I think it's far enough away, you can prove it. What test scores bind the middle 50% of the data? Well, the middle 50%, remember, this is 25% of the data, and this is 25% of the data. So the IQR, 73 to 90, is the middle 50% of the data. Half the students are in that range. What score was the cutoff for the top 25%? Well, that's 90. Q3. The teacher asked the lower half of the test scores to do test corrections. What students have to do test scores? Well, that's students from the minimum, the low end, to the median. I meant to put this underneath. Or Q2, all right? And that was 84.5. Okay? And the homework is what we'll do in class next day. There you go.